Have you ever looked up at the night sky and wondered what's out there? Sometimes, something truly alien passes through. Not long ago, our solar system was visited by a mysterious object from another star. This interstellar traveler named 3I Atlas sparked both curiosity and concern. Was it a threat? Where did it come from? Where was it going? For the first time, we had the technology to answer these questions. Interstellar objects are rare. Only two had ever been confirmed before: Oumuamua and Borisov. When 3I Atlas was detected, astronomers worldwide mobilized. Its high speed revealed its origin. It wasn't from our solar system, just passing through. Its path brought it close enough for detailed study, raising urgent questions about its nature and trajectory. The James Webb Space Telescope, humanity's most advanced observatory, was assigned a critical mission: observe, analyze, and determine if this visitor posed any risk. The stakes weren't about disaster, but about understanding our place in a galaxy full of wanderers. The universe had sent us a message. It was time to decode it. This is the story of how we met an uninvited guest from beyond, and what we learned. Let's follow 3I a Nastandak Bear, and Destiny Omri. Thus, on its brief, extraordinary journey through our cosmic neighborhood, 3I Atlas, the third confirmed interstellar object, was discovered by the Atlas Survey in Hawaii, a system designed to spot near-Earth threats. Unlike typical asteroids or comets, it moved too fast and at the wrong angle to belong to our solar system. Its predecessors, Oumuamua and Borisov, were each unique. One rocky and mysterious, the other a classic comet. 3I Atlas offered a rare third data point, a new chance to study the diversity of interstellar visitors. Early observations hinted at a faint coma, suggesting a comet-like nature. The discovery highlighted how much our detection capabilities have improved. These objects were invisible to us just a decade ago. Automated sky surveys like Atlas and Pan-STARRS now catch these fleeting visitors with increasing frequency. Each new detection helps us understand how many such objects roam the galaxy and what they're made of. 3I Atlas wasn't just a rock or a chunk of ice. It was a scientific treasure chest racing through our solar system at over 100,000 kilometers per hour. Our window to study it was short, but the potential for discovery was enormous. What secrets would this messenger from another star reveal? The race was on to unlock its mysteries before it vanished forever. The world's astronomers prepared for a rare cosmic encounter. To unravel the mysteries of 3I Atlas, astronomers turned to the James Webb Space Telescope. With its massive gold-coated mirror and infrared vision, JWST could see what no other telescope could. Positioned at the stable L2 point, far from Earth's heat and light, Webb is perfectly suited for faint, cold objects. Infrared is key. Interstellar objects glow faintly in these wavelengths, revealing their size and temperature. Webb's instruments can also detect the chemical fingerprints of water, carbon dioxide, and organics in the object's coma. Recognizing the urgency, JWST's director allocated precious observation time to 3I Atlas. This was a rare opportunity, one that couldn't be missed. The telescope's golden eye turned toward the fleeting visitor, ready to capture data before it slipped away. The world waited for answers from the edge of the solar system. What would Webb see in this cosmic interloper? Observing 3I Atlas with JWST was a technical challenge. It's a fast-moving, faint target. The telescope's tracking system had to follow its predicted path with extreme precision. Webb used its near-infrared camera, NIR-CAM, to capture deep images, pinpointing the object's position and searching for a coma or tail. These images refined its orbit and revealed its brightness. Next, the near-infrared spectrograph, NIR-SPEC, spread the object's light into a spectrum, searching for chemical signatures. Each molecule leaves a unique barcode in the infrared, allowing astronomers to identify water, carbon dioxide, and more. This combination of imaging and spectroscopy provided a complete picture where 3I Atlas was going and what it was made of. The data streamed back to Earth, where scientists eagerly awaited the results. Would this interstellar visitor resemble a comet, an asteroid, or something entirely new? The answers were hidden in the faint glow captured by Webb. Soon, the secrets of 3I Atlas would be revealed. The first breakthrough from JWST was a dramatic improvement in our knowledge of 3I Atlas's trajectory. Before Webb, its orbit was uncertain, collision with Earth was unlikely, but not impossible. NORCAM's precise images shrank the uncertainty, allowing astronomers to model its path with confidence. Sophisticated computer models, using the new data, showed exactly where 3I Atlas would travel for years to come. The refined orbit revealed a strongly hyperbolic path, an open curve, not a closed loop. 3I Atlas would swing around the Sun and head back into interstellar space, never to return. The data also allowed scientists to check for non-gravitational forces, like jets of gas that can nudge comets off course. Minimal outgassing was detected, meaning its path was almost purely gravitational and highly predictable. The eccentricity of its orbit, about 3.5, confirmed it was just passing through, not bound to the Sun. For comparison, Pluto's orbit is much less eccentric. The verdict was clear. 3I Atlas was a cosmic tourist, not a threat. The JWST data turned uncertainty into certainty. We could now track this interstellar visitor with pinpoint accuracy. The risk to Earth? Zero. With JWST's precise data, astronomers mapped 3I Atlas's journey through the solar system. It entered from above the ecliptic, the plane where most planets orbit, on a steeply inclined path. It crossed Neptune's orbit and headed inward, reaching its closest approach to the Sun, just inside Mars's orbit. The crucial detail, its path never came close to Earth. At its nearest, 3I Atlas would be over 150 million kilometers away, the same distance as Earth to the Sun. The timing was also reassuring. When it crossed Earth's orbital plane, our planet would be on the opposite side of the Sun. There was never any danger of a collision. This visualization replaced fear with understanding, a graceful arc, not a threat. The data-driven map showed the power of science to turn cosmic mysteries into clear answers. 3I Atlas's journey was a beautiful demonstration of celestial mechanics, not impending doom. The final analysis was definitive. 3I Atlas posed no threat to Earth. JWST's high-precision data confirmed its closest approach would be vast and safe. The public could rest easy. This visitor was harmless. The process, from discovery to risk assessment, worked flawlessly. Spectroscopy revealed water ice and carbon dioxide, confirming 3I Atlas as a comet-like body, similar to Borisov. Its minimal outgassing made its path highly predictable. This was not an alien probe, but a familiar piece of planetary debris from another star. In every way, 3I Atlas was a fascinating, well-behaved guest, one we were lucky to study. The JWST campaign achieved its main goal. 3I Atlas's trajectory was mapped with unprecedented accuracy. Its safe passage was confirmed, no impact risk, no cause for alarm. Infrared spectroscopy revealed water ice and carbon dioxide, identifying it as an interstellar comet. This adds to our tiny but growing sample of such objects, hinting that icy wanderers may be common in the galaxy. The faint outgassing suggested an old, processed body, making its path even more predictable. The event was a real-world test of our planetary defense systems, and they passed. From detection to analysis, the process was swift and effective. We proved we can find and study potential threats long before they become dangers. The story of 3I Atlas ends with reassurance and a challenge. We learned much from this harmless visitor, but more interstellar objects are coming. Soon we'll detect them regularly, turning rare events into routine science. Each new discovery will teach us about the galaxy's building blocks and test our readiness. 3I Atlas was a dress rehearsal. The next visitor might not be so benign. Are our systems ready for a real threat? The future will test our vigilance and ambition. For now, we bid farewell to 3I Atlas and look to the stars, prepared for whatever comes next.